Welcome to this premium DrPinnacle Enterprise Consulting briefing. Today, we're setting the stage to deploy truly trustworthy AI. We're tackling a topic that is absolutely crucial for any enterprise operating in today's tech landscape, and we are going to break the whole thing down step by step in this explainer. Let's dive right in.
Most organizations securing AI systems are only protecting infrastructure, not the intelligence itself. Now that is our starting point today because it represents a massive, often completely invisible vulnerability. Think about traditional cybersecurity paradigms for a second. We're talking firewalls, identity management, strict access controls. Well, those are dangerously mismatched when you apply them directly to probabilistic large language model systems. Honestly, you could have literally the most secure server room on the planet, but if your model can just be sweet-talked into giving up sensitive data through a clever prompt, yeah, your infrastructure security means absolutely nothing.
So here's our roadmap for this explainer. 1. The intelligence protection gap. 2. AI safety versus AI security. 3. The mathematical foundations. 4. Model sourcing and validation. 5. Continuous evaluation framework. And finally 6. Deploying intelligence not risk.
Okay, starting off with Section 1, the intelligence protection gap.
Trustworthy AI requires so much more than just throwing up network firewalls. It really demands a holistic approach. For an AI system to be truly trustworthy, it has to be accurate and reliable. That means it performs consistently on real-world, messy data. It also has to be safe from unintended harms, secure against malicious threats, aligned with your specific business and human values, and finally, it absolutely has to meet stringent compliance standards. Think things like the EU AI Act or NIST frameworks. And here's the kicker. If you miss even one of these pillars, you aren't going to achieve true, sustainable business impact.
Moving right along to Section 2, AI safety versus AI security.
Now, these two vital domains are dangerously conflated all the time, but they are entirely distinct. AI safety is an inward-looking discipline. It's all about alignment, controllability, truthfulness, and harmlessness. It ensures the model basically behaves well on its own accord, preventing unintended behavior. On the flip side, AI security is outward-looking. It focuses on prompt injection defense, data privacy, preventing model and IP theft, and stopping complex adversarial attacks. So, to put it simply, safety ensures the model doesn't accidentally do bad things, while security protects the model and its data from external malicious actors who are actively trying to force it to do bad things. Make sense?
All right, let's get into Section 3, the mathematical foundations. To actually manage AI effectively, you have to wrap your head around expected risk, which is mathematically represented as R of theta. And look, this isn't just academic theory. This is exactly how we quantify a model's true reliability and generalization on unseen data. It's the mathematical expectation of loss across an entire data distribution. It's kind of like calculating the exact mathematical probability of your house catching fire under 1,000 different conditions, rather than just slapping a smoke detector on the ceiling and hoping for the best. For product managers and executives out there, you need to know that managing AI means mathematically minimizing this expected loss. It's a rigorous probabilistic calculation, not just a binary software patch.
And building right on top of that concept is ECE, or expected calibration error. This metric is a total game changer for trustworthy AI. ECE measures the gap between a probabilistic model's actual accuracy and its stated confidence level. So why does this matter so much? Because an LLM must not confidently hallucinate. If a model is wrong, we want it to be uncertain, right? But if it's highly confident and simultaneously mathematically inaccurate, your ECE skyrockets. ECE basically grounds a model's probabilistic outputs with cold, hard math, so you know exactly when you can trust it.
So how do we actually optimize for safety using these mathematical foundations? Well, we rely heavily on preference optimization and alignment techniques like RLHF, reinforcement learning from human feedback. This is a highly scientific process of mathematically tuning the model to minimize toxicity and to drive that jailbreak success rate down as close to absolute zero as humanly possible. We are essentially mathematically rewarding the model for producing safe, aligned outputs. Conversely, AI security optimization has its own distinct mathematical foundation. Here, the end goal is maximizing robustness, and we do this by mathematically bounding the maximum loss against engineered input perturbations. What does that mean? Basically, adversaries are going to try to slightly tweak inputs to break the model's guardrails. Security engineering in AI means ensuring that even with those tiny, malicious tweaks, the expected loss remains tightly bounded and the whole system stays secure.
Okay, let's look at Section 4, model sourcing and validation.
The choices you make around sourcing completely dictate your security perimeter. If you're using proprietary, hosted models, think OpenAI's ChatGPT or Anthropic's Claude, you're relying on vendor-managed cloud infrastructure. Their safety guardrails are largely baked right in, which is great, but your data is leaving your perimeter. On the other hand, if you're utilizing open-source models and running them via self-hosted platforms like Allama or VLLM, you can host them entirely on-premises. That gives you total data security. But, and this is a big but, the burden of configuring those AI safety guardrails and mathematically minimizing that expected risk we talked about, that falls 100% on your organization. The security and safety perimeters are vastly different depending on which route you take.
Next up, Section 5, Continuous Evaluation Framework.
So all of this theory builds directly into the DrPinnacle end-to-end practice framework. Governance is an iterative, lifecycle process, guys. It is not a one-and-done checklist. You start by defining your use cases and governing data sourcing. Then you build or select your models, mathematically validating their robustness. Step 3 is continuous benchmarking while securing the infrastructure. And finally, deploying with strong guardrails and, crucially, monitoring continuously.
In a live production environment, this continuous monitoring has to be absolutely relentless. Live production data feeds into the model and it generates outputs. But those outputs don't just go straight to the user unchecked. They also flow through dedicated evaluators, which are constantly checking for safety, security, and performance. This continuous feedback loop feeds straight into an alerts and metrics dashboard. This right here is the vital necessity of modern AI governance: relentless, real-time evaluation against your baselines.
To make that dashboard actually effective, here are the non-negotiable metrics every enterprise must monitor live. Performance metrics like accuracy and F1 scores, our calibration metric, ECE, to catch those confident hallucinations, the toxicity rate and jailbreak success rate to measure safety and alignment, and finally, data and concept drift to ensure the model isn't secretly degrading over time. By tracking these, you're taking these invisible probabilistic risks and turning them into highly observable managed data streams.
Bringing it home with Section 6, Deploying Intelligence, Not Risk.
If you take absolutely only one thing away from this explainer today, please let it be this. AI safety protects humanity from AI behavior. AI security protects AI systems from adversaries. Enterprises require both. You just cannot afford to prioritize one while ignoring the other. They are two entirely distinct mathematical and operational disciplines that combine to create trustworthy AI.
And I will leave you with this stark reality. Organizations deploying AI without rigorous safety engineering and continuous security governance are not deploying intelligence, they are deploying unmanaged probabilistic risk. The math simply doesn't lie, and traditional IT firewalls won't save you from a misaligned probabilistic model. So the question you really need to ask yourself and your teams today is this: what exactly is your organization deploying right now? Intelligence or unmanaged risk? Thank you so much for joining me in this DrPinnacle briefing. Keep evaluating, keep governing, and stay curious.